Today we are going to be graphing the 6 basic trig functions. This is an extremely important thing that I need you to take with you to calculus. You'll be using the basic trig graphs from here on out, just like you need to know basic unit circle trig values. So, first of all, to graph the trig functions, we no longer think of theta as being an angle in standard form whose vertex is the origin and initial ray is on the positive x-axis. We are no longer doing this for theta. We're no longer going like around to get theta. Instead, theta is on the x-axis. Theta is the x-axis. So theta is what we think of as x. All right? And we don't have to have a theta here, we can just have an x there. So we are graphing x versus y, but x is the angle because it's the argument of the trig function. So we're going to begin by graphing sine x. So sine, if we think of sine values, if I have 0, sine of 0 is 0. Sine of pi over 2. Remember when we did this before, we thought of the unit circle and we had these values. This was 1, 0, this was 0, 1, negative 1, 0, and 0, negative 1. And sine was the y coordinate on the unit circle. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi, we're back to 0. Sine of 5 pi over 2, we're back to 1. Then back to 0, then negative 1, then back to 0. We connect these with a smooth curve, okay? Keep in mind that sine of pi over 6 we're already up to 1/2, right? So this sine curve does this. And it keeps on going. It keeps on going. In both directions it keeps going. So this keeps on going back here, like that. Keeps on going forever. Okay? So where on this graph is our old quadrant 1? Well, quadrant 1 is between 0 and pi over 2, right? Between 0 and pi over 2, we're in quadrant 1. Between pi over 2 and pi, this is quadrant 2, quadrant 3, and quadrant 4. And then it repeats itself. Now we're back to quadrant 1. Quadrant 2, quadrant 3, quadrant 4. Repeats itself. So sine is still positive in quadrant 1 and quadrant 2, and then sine is negative in quadrant 3 and quadrant 4. What is the domain of sine x? Sine x can be any real number. All real numbers, no exclusions. So negative infinity to infinity if you prefer interval notation. What is the range of y is equal to sine x? What are the possible y values? Well, y can only be from negative 1 to 1, never above 1, never below negative 1. So from negative 1 to 1, that's the range. The period. The period is how often, what is the cycle? How big is the cycle until it starts repeating itself? Well, we started at 0. Here we were back to 0, but we're going below rather than above. So the period will be, once we get to 2 pi, we do the same thing again. So the period is 2 pi. It's how far do you go until you start to repeat yourself. So it repeats every 2 pi units. Okay? So the same thing for cosine x. For cosine x, Again, I'm using the unit circle and these values, but this time the x coordinate will be the cosine value. So at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is -1. 3 pi over 2, cosine is 0. 2 pi, we're back to 1. And then it repeats itself over and over and over again in both directions. We connect these with a smooth curve. Oops, got those off. That should have been on 0, and that should be on 1. There you go. Alrighty. So, where's quadrant 1? Quadrant 1, cosine is positive, above the x-axis. Quadrant 2 and 3, cosine is negative, below the x-axis. Quadrant 4, cosine is positive. So everything jives with what we've been doing before. The domain is all real numbers. The range is still -1 to 1. The period, how often, how far do you go until you start repeating the exact same cycle? The period is still 2 pi. Repeats itself every 2 pi units. Okay. Tangent. Let's do tangent. So, recall that tangent is sine divided by cosine. Therefore, tangent x is undefined whenever cosine is 0. We cannot divide by 0, right? Undefined. That means the graph will have asymptotes whenever cosine is 0. When is cosine 0? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and then backwards, right? Okay. In addition, tangent of x is 0 whenever the numerator is 0, whenever sine is 0. And sine is 0 at 0, pi, 2 pi, 3 pi, etc., 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 and backwards, and the negatives. One more thing, tangent is 1 at pi over 4 and 5 pi over 4. And tangent is -1 in the other quadrants. So let's go draw all these things. At all of the pi over 2 units, we're going to have vertical asymptotes. That is not part of our actual graph. I'm going to do that in a nice light color. I have a little yellow I can use. So I'm going to use to draw my asymptotes at all of the pi over 2's. So pi over 2, 3 pi over 2, 5 pi over 2, etc. Get all of our asymptotes drawn. And don't forget to go on the negative direction too. Probably could have had some of these drawn before I started this video. I know it's boring to watch. Okay, got all of our asymptotes drawn. Now we're going to draw our zeros. I'm going to get my main color here for the zeros. So tangent is 0 whenever sine is 0, and sine is 0 at 0, pi, 2 pi, 3 pi, all of the whole pi's. That's when sine is 0. Okay? Now, tangent is 1 at pi over 4. Pi over 4 is halfway between 0 and pi over 2. So tangent is 1 right here. Tangent is negative 1 in the 4th quadrant, right there. Tangent is 1, negative 1. 1, negative 1. We're just going to repeat that pattern. The graph of tangent is asymptotic. It does this. It looks slightly like the curve y equals x cubed, but it is not y equals x cubed. This is tangent. The slope is 1 right here. If it was y is equal to x cubed, the slope would be flat right there. Tangent has asymptotes. If it was y is equal to x cubed, that does not have any asymptotes at all. So I'm going to keep on finishing my little tangent legs. This is a very noisy pen. Keeps on going in both directions. Alrighty, so there's tangent. Very different from sine and cosine. It's not a wave. Sine and cosine are waves. Alright, where's our old quadrants? Okay, there's 0. So this is quadrant 1, and in quadrant 1 tangent is positive. In quadrant 2 tangent is negative, but in quadrant 3 tangent is positive. Quadrant 4 tangent is negative, and then it repeats. Asymptotes, tangent has asymptotes at pi over 2, 3 pi over 2, 5 pi over 2, etc. in both directions. In both directions. Okay. One way we can write that is k pi over 2, where k is every odd integer. Okay. The domain. The domain is, what's the domain? Domain, we have to exclude all of those asymptotes. It's all real numbers except those asymptotes. So all real numbers where x is not equal to k pi over 2, where k is an odd integer. What about the range? What y values are being covered? All of them. All of them. So all real numbers. What is the period? How far do you go until you start to repeat yourself? Only to pi. At every pi units you will repeat the graph of tangent. Okay, one more thing to talk about tangent before we go on. What is the limit as x approaches pi over 2 from the left? This is from the left. Here's pi over 2. Here's the left of pi over 2. Where is tangent? Tangent is going to infinity. So this is infinity. What about tangent of pi over 2 from the positive side, from the right? Here's pi over 2. On the right, the graph is down going to negative infinity. So this would be negative infinity. What about negative pi over 2 from the right? Negative pi over 2 from the right. That would be negative infinity. A little reminder on limits there. Okay, let's talk about cotangent. We're doing all 6 basic trig functions. Let's talk about cotangent. So recall that cotangent is the reciprocal of tangent. Therefore, cotangent is cosine over sine. Cotangent will be undefined whenever sine is 0. And that is at, 0. At 0 and pi and 2 pi and 3 pi, etc. in both directions. Okay? That's where we'll have asymptotes. In addition, cotangent is 0 whenever the numerator is 0, so cosine is 0. So let's draw our asymptotes at all of the whole pi's. All of the whole pi's, cotangent will have an asymptote. Again, I should have had these drawn already, but oh well, didn't get there. In class, I'll be up at the board doing this. It's going to be hard to see that on the x-axis. I'm sorry, on the y-axis. I may even do it just slightly on the other side of that y-axis, just so we can observe those asymptotes, or that asymptote. The other ones we can see pretty well. All right, there are all of our asymptotes for cotangent. And then wherever sine is 0, and when sine is 0, we have a 0 for cotangent. So I think I said that wrong. Wherever cosine is 0, cotangent has a 0. So pi over 2, 3 pi over 2, all of the k pi over 2's, where k is an odd integer. All of those guys. Now, in the first quadrant, between 0 and pi over 2, all of the values are positive. So cotangent is positive, and at pi over 4 will be a positive 1. In the next quadrant, quadrant 2, cotangent is negative. So at 3 pi over 4 will be at negative 1. That first leg of cotangent does this. It looks similar to the graph of tangent, but it's going in the other direction. And that's how all of these will go. Probably didn't have to put all of these. I didn't have to go all the way to 6 pi, but I wanted you guys to see how it is repeating. Okay, I'd even draw a little bit up here, show what that's doing. So very similar to the shape of tangent. I think of it as kind of being a little bit backwards. Okay. Cotangent. Very good. Alrighty. Let's answer these questions. Asymptotes. Cotangent has asymptotes at all the whole pi's, at 0, pi, 2 pi, etc. So at k pi, where k is any integer, the domain then is all real numbers except those. Okay, what is the range? All real numbers. All of the y values are covered. The period, how often does it repeat itself? Every pi units. So the period of tangent and cotangent is pi. Couple limit questions. What is the limit as x goes to pi from the left? Pi from the left. So here's pi. From the left, cotangent is going to negative infinity. So this one is negative infinity. What about pi from the right? Pi from the right, positive infinity. And negative pi from the right. Here's negative pi coming at it from the right. Cotangent is going to positive infinity. I said that wrong. Let me redo this one. I hope I said it right, but I wrote it wrong. Let me do it again. Pi from the right. Pi from the right. We're up here going to infinity. Pi from the right. This will be infinity. Alright. Secant and cosecant. Getting all of our trig functions in graph, basic graphs. Okay, secant is the reciprocal of cosine. So we're going to, whenever I'm drawing the graph of secant or cosecant, I draw its reciprocal function, and we're going to draw it very lightly. I have the advantage of being able to do this with my yellow, so I'm going to do this with my yellow, but if you just want to do it really lightly, we're going to do cosine. Cosine, I think of as cosine starts at 1. Cosine starts at 1. And then it has zeros at pi over 2, 3 pi over 2. So we're going to be at negative 1 for pi, 0, then back to 1. 0, negative 1, 0, 1. 0, negative 1, 0, 1. And on the other side of those. So I'm going to draw all of my cosine. You can draw it very lightly with your pencil. Okay. So, since secant is 1 over cosine, everywhere cosine is 0, secant will have an asymptote, a vertical asymptote. So wherever cosine is 0, we have a vertical asymptote for secant. So secant has asymptotes everywhere that tangent has asymptotes. All of the pi over 2's asymptotes. Tangent is sine over cosine. Secant is 1 over cosine. So they have the same asymptotes. Very different graphs, but the same asymptotes. Once again, I have plenty of these so we can really get a good feel for what secant looks like. Alrighty. Now, secant, since secant is 1 over cosine, everywhere that cosine is 1, secant will be 1. Everywhere that cosine is negative 1, secant will be negative 1. So the graph of secant, wherever cosine is 1, secant will be also 1. wherever cosine is -1, secant will be -1. So these points that are on cosine are also on secant. Those points, 1 and -1. Okay, now secant is the reciprocal. So wherever cosine is a half, secant will be 2, right? Wherever cosine is a half, secant will be 2. The graph is going to look like this. It's these U's. I think of these as being like U's. Okay, you get the idea. That, what I've drawn in purple here, that is secant. The yellow just helps us know where to put the secant curve. Okay, secant has asymptotes at all the pi over 2's. So pi over 2, 3 pi over 2, 5 pi over 2, etc. in both directions. K pi over 2, where K is odd. Okay. The domain is all real numbers except the x values I'm going to write that as k pi over 2. The x values that make the asymptotes. Okay. What is the range? What is the range? What y values are there? Well, -infinity to 1 and 1 to infinity. Nothing between -1 and 1. So -infinity to -1, including -1, union with 1 to infinity, including 1. The period, how often does it take to start repeating? 2 pi. 2 pi. Couple limits. As x goes to infinity to pi over 2 from the left. Pi over 2 from the left. That will be infinity. Pi over 2 from the right. Pi over 2 from the right, -infinity. Negative pi over 2 on the right. Negative pi over 2 on the right. That's infinity. Okay. Cosecant. Cosecant. All right. Recall that cosecant is 1 over sine. So we're going to draw the graph of sine and draw it very lightly or with a different light color so that we can draw cosecant. So sine, I think of as sine starts at 0. Cosine starts at 1. Sine starts at 0. Then it goes up to 1, back to 0. -1, 0. 1, 0, -1, 0. Keeps on repeating itself in both directions. I want you to get to where you can draw this graph of sine in your sleep. You know exactly where it goes, exactly how to draw it. Okay, everywhere sine is 0, we have a vertical asymptote. So at all the whole pi's, because that is where sine is 0. And cosecant is 1 over sine. Alrighty, and just like we did with secant, everywhere that sine is 1, cosecant will also be 1. So there's our first u of cosecant. Here's our second u of cosecant. For our third u, we're back to where we started up on top. And then down here, etc. Okay. Alrighty, asymptotes at all the whole pi's. I'm just going to say k pi, where k is any integer. Okay, that's x is equal to k pi. Domain, all real numbers except k pi, where k is any integer. The range is all real numbers. No, it's not all real numbers. All real numbers except from -1 to 1. So, negative infinity to -1, including -1, union with 1 to infinity, including 1. The period, once again, is 2 pi. Repeats every 2 pi units. Couple of limits as x goes to pi from the left. Pi from the left is positive infinity. The function is going to positive infinity. Pi from the right. Pi from the right, negative infinity. Negative pi on the right. Negative pi on the right, negative infinity. If you know the graph, you can answer those questions easily. Okay, going to talk about a couple of aspects of the graphs now. I'm going to talk about amplitude and a little bit more about period. Amplitude. The amplitude is, you only find amplitude of sine and cosine curves. The others do not have amplitude. Okay? Amplitude is only applicable to sine and cosine. The amplitude is half the distance between the max and the min values of the function. Okay? Amplitude is the absolute value of a when your function is in this form. So if you just have y is equal to sine x, the amplitude is 1. Remember our graph of sine? Let me pull it back up. There's our graph of sine. From the maximum to the minimum, the max is 1, the minimum is -1. Half of that distance from 1 to -1 is 1. The distance between those is 2. Half of that is 1. Okay? For period. The period, if b is a positive number, then the period is the coefficient of your x in either the sine or the cosine. The period is given by 2 pi, which I think of as This is the normal period for sine and cosine divided by b, that x coefficient. This is the way that I would really love for you to think about period. The normal period, whatever that is, divided by your x coefficient. Okay? So let's approximate the amplitude and the period for these functions. So amplitude, the amplitude here is, okay, there's 0.5, there's negative 0.5, the distance is 1, so the amplitude is 1/2, or 0.5. What is the period? How often, how long does it take until you start repeating yourself? I find a whole cross piece here, 0. How far do you go until you get to 0? Pi over 2. I'm sorry, how far do you go till you start repeating yourself? Because you get to 0 here, but you're not repeating yourself, because here you're going above the x-axis and here you're going below the x-axis. You repeat yourself every pi over 2 units. Let's do the next one. The amplitude here, well, the high is 3, the low is negative 3. Half of that distance is 3. The period, from here to here, we start repeating ourselves. So that period would be 4. Okay, what about this one? Amplitude. Where's the high? Well, the high is at 3. What's the low? The low is at negative 1. That distance is 4. Half of 4 is 2. Amplitude is always positive. Okay? The period. What's the period here? Well, I'm going to find a spot where I'm at like a cross, like right here. Do you see right here where it crosses the grid? Where does that start repeating itself? Right here, right? Looks like it starts repeating itself right there. Hard to tell exactly from this one, but that's my guess, my best guess. So that distance is 8. So the period is 8 units. Next one. Amplitude. High, low. The high is 5, the low is negative 3. That distance is 8. Half of 8 is 4. Okay, the period. I'm going to try to find a spot where they kind of cross. Looks like it kind of crosses right here. Yeah. So where does it begin again? It's hard to tell from this side. It really is hard to tell from this side, but I'm wondering if it's right there. Is it right there that it begins again? Let's go the other way. Yeah. Oh, no, not there. The next one over, huh? Right here? I think so. I think that this distance is the period. So what is that distance? That distance is 8. So the period is 8. 8 units. Okay? Keep an eye on the time here. I'm wondering if I'll be able to get through all of these in class. Maybe, maybe not. We will see. Alrighty. Okay, let's write the equation for this function. Let's write the equation for this function. Well, first of all, I see that the amplitude is 1/2. So I know it's going to be 1/2 in front. Okay? This looks like the sine curve because we're starting at 0. So it looks like sine. I'm going to go with it. Now what about the period? The period here is pi over 2, right? The period is pi over 2. That's how far we go till we start repeating. But period is always the normal period divided by the x coefficient. The normal period for sine is 2 pi. So this little equation will give me my x coefficient. I'm going to call that b. Solve this for b. Cross multiply, we get pi b is equal to 4 pi, so b must be 4. Okay, we can put that in parentheses if we like. Oh, it said to call it f, so I'm going to call it f. Okay, so that's an equation for this graph. Let's do another one. Alrighty, what's the amplitude? First of all, what's the amplitude? The amplitude looks like 3. Amplitude is 3. Okay, cosine or sine? We're starting up high, that's a cosine. You start up high, that's a cosine. Now for the period. Here's our period, right? The period is 8 pi over 3. So I'm going to set up the little equation. 8 pi over 3 is equal to normal period divided by b. Solve for b. Cross multiply. Divide by 8 pi. 6 over 8 is 3/4. 3/4 x. Let's do another one. Here's the curve. This time looks like a sine curve because we're starting at 0. So sine. What's the amplitude? 2. What's the period? The period is 4. So I'm going to set up the little equation. 4 is equal to 2 pi over b. Solve for b. Cross multiply. Divide by 4. b is pi over 2. One more like this. Sine or cosine? Well, it's going through the origin. I'm going to call this a sine. What's the amplitude? The amplitude is 1. However, sine normally goes up first, and this is not going up first. It's going down. It's flipping over the over the x-axis. So I need to make the whole thing a negative. Negative sine. Okay. Now for my period. What is the period? The period is 2. So I'm setting up normal period over b is 2. Cross multiply. 2b is 2 pi, so b must be pi. Alrighty. What is the amplitude and period of this function? Well, the amplitude is the absolute value of that coefficient, so just 2. The period is the normal period for sine, 2 pi, divided by 5. Amplitude is the absolute value of 7, so 7. Period, normal period is 2 pi, normal period of sine is 2 pi, divide that by 9. Amplitude is 3, period. Normal period is 2 pi. Divide by 2/5. I'm going to multiply top and bottom by 5. That's 10 pi over 2, which is 5 pi. Let me plug in. Low on battery. Okay, doke. Almost there. Let's do a couple of graphs. Let's sketch the graph of 2 sine of pi over 2x. Amplitude is 2. The period is normal period divided by pi over 2. Multiply top and bottom by 2. And we get 4 pi over pi, which is 4. So the period is 4. It's positive, so it's sine, so I'm starting at 0. I'm going to start repeating myself. Once I get to 4, I'm going to repeat myself. So since it's a sine curve, I cut this into 4 pieces, right? Sine is going to be 0 at halfway between my period, yeah? It's going to be up, then at 0, then down, then at 0, and then repeat itself. But we're going to go up to 2, and down to -2, and then repeat. Right? So up, down, oops, my goodness. I can do better than that. Apparently not much better than that though. Kind of got into my groove. And then we also go all the way through. If they show a grid going all the way over here, then you've got to go all the way over there. Keep on going. There's the graph of that curve. Okay. What about this one? It's another sine. This time there's a negative, so I'll need to be careful about that. We're going to reflect across the x-axis. Okay, the amplitude is 3, and the period is the normal period divided by 1/4. Multiply top and bottom by 4, and we get 8 pi over 1, so 8 pi. Okay, it's sine. I start at 0. 8 pi, after 8 pi, that's my period. I'm going to start repeating myself after that far. So halfway, I'll be back to 0, right? Half of that, I'm at my max or min. Since I'm reflecting across the x-axis, normally I go up, but this time I need to go down because we're reflecting across the x-axis. So I go down, then to 0, then up, then to 0, then down, then to 0, then up, then to 0, then down. All that keeps on going. Okay? Okay. Let's do a cosine. All right, the amplitude is 2. The period is the normal period divided by this 2, which is pi. The period is pi. It's a cosine. Cosine usually starts at 1, but since the amplitude is 2, I multiply that by 2. After pi units, I will begin repeating myself. Okay? Halfway on cosine, halfway, I'm at my minimum value, because half of that I'll be at 0. Here's that one period of cosine. And then we'll repeat ourselves. That is not right. That is not right. I'm ahead of myself. I'm doing what I'm going to be doing. Ugh. That does not erase completely. I was hoping it would. Okay, let me do that again. Yes, the period is pi, so we'll be back there. However, halfway, I'm not on the x-axis. I'm down at the minimum. I'm down at -2. Half of that, I'm at 0. This is a very skinny graph. There we go. Better. So, halfway, I'm at 0, and then down to -0, then positive. Here's one more period. Halfway. Keeps on going. Same thing on this side. There we go. It's very skinny. Okay. Try to make it as curvy as you can. All right. So that is the graphs of the basic trig functions with a little extension into amplitude and period.